Now we're really getting wild. This is a fifth example problem of variable geometry. And we actually, for this particular system, we actually end up with 5 different equations in a nonlinear system of equations, which is really complex. But just for kicks, I'll show it to you. If you're looking for a good time this weekend, you can figure it out yourself. And so the previous examples were right triangles. But what if we have a general triangle? So what if we have a fixed length D1 and then a spring on this leg, and we apply this weight and the whole system sags? My final free body diagram is a force P, a force Fs, an angle theta here, and an angle phi here, which is different than theta. And my unstretched length of my spring is D2. And of course, this D1 stays constant. My known values are D1, D2, which is the unstretched length, the weight that I apply, and the spring constant. I've got 5 unknowns. I've got theta, phi, L, Fs, and P. If this is my free body diagram, my equilibrium equations are Fs cosine theta minus P cosine phi is equal to 0. So that's a valid equation, you understand that. In the y direction, I have Fs sine theta plus P sine phi minus W is equal to 0. You understand that. My spring force Fs is equal to the spring constant times the current L minus the unstretched length, which was D2. That gives me 3 equations, but I still need 2 more equations. And so I can use the law of sines from this triangle. I can basically say sine of phi over L is equal to sine of theta over D1. And that leads to a 4th equation. And then I can also use the law of sines, where the length of this side is D1 plus D2. And if I call this angle psi, and psi is equal to 180 minus phi minus theta. And so I can write law of sines for the whole triangle. And so sine of psi divided by D1 plus D2 is equal to sine of theta divided by D1. And that gives me a 5th equation. So those are 5 equations. And they're all equations you understand. You understand the equilibrium. You understand the spring. You understand the law of sines. So these are not unknown to you. But this is cool. But literally what this says is I can hang this weight from the system and let it fall, and I can actually calculate the equilibrium position of that system, which is pretty cool. So in a separate video, I'll actually pull up Excel and show you. I implemented this, and I basically had to iterate for this in Excel using Solver, and I'll show you in a separate video how to do that. But this is the setup of the problem.